This is the first part of test 4 review, which is all about logarithms. Right up here, you have 3 formulas that will be given to you on a test, but you have to know which formula applies to a particular problem. So number 1, find the accumulated value of an investment of $30,000 for 5 years at an interest rate of 6% if the money is compounded quarterly. Quarterly tells you that we're using this formula right here. So we have A equals P times 1 plus R over N to the T. So we've got an investment of $30,000, that's our P. 5 years is T. 6% is our rate, and it's compounded quarterly, which means N equals 4, because quarterly means it's compounded 4 times a year. So all we have to do is plug things in appropriately and use the calculator, and we've got an answer. So this is 30,000 in for P. 1 plus R, which is the rate. It's got to be written as a decimal. To change a percent to a decimal, move the decimal point 2 places to the left, over N, which is 4 because this is quarterly, all raised to the 5th power. You can enter that in the calculator exactly as you see, and it should come out to be $40,405.65. Now the next one says find this accumulated value of this investment of $27,000 for 4 years, blah, 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 money compounded continuously. When you see the word continuously, that's telling you that you're using the PERT formula. A little bit easier to use because there's less to it. So here's our P. 4 years is time. 6% again, that's our rate, compounded continuously. All we have to do is plug in 27,000 for P. E stays as E to the R, which is 0.06 times 4. Type that in the calculator, and you will get 34,323.73. Write each equation in its equivalent exponential form. This is in log form. To go back to equivalent form, we grab the base to this power equals 125. And that's all you have to do is convert it. Grab the base to this power equals 8. These problems are telling you are not allowed to use a calculator on the test. This will be a separate part of the test. To do this evaluation, my suggestion is that you put equals x so that we have a logarithm equation. We want to convert it back to exponential form. So it's 3 to the x equals 81. What we have to come up with is what power goes on 3 to get 81. Remember, no calculator. If you have the calculator, you could just type it in. But what we want to do here, or the easy way to do this by hand, is you do the successive divisions. 3 goes into 81 27 times. 3 goes into 27 9. 3 goes into 9 3 times. 3 goes into 3 once. When you get down to 1, you know you're finished. Why did I start dividing by 3? Because this base over here is 3. So 81 is the same as 3 to the 1, 2, 3, 4. And if that's equal to 3 to the x, then obviously that means x equals 4. Same exact steps over here, put equals x. This is 2 to the x equals 64. I need to find out what power goes on 2 to make 64. So I will do the division. This comes out 32. 2 into 32 is 16. 2 into 16 is 8. 2 into 8 is 4. 2 into 4 is 2. And 2 into 2 is 1. So 64 is the same as 2 to the 1, 2, 3, 4, 5, 6. So if 2 to the x equals 2 to the 6, then that means x must equal 6. Put equals x. This is now 3 to the x equals 1 over 27. Now, you have to do a little bit of thinking here. X is going to have to be a negative, because the only way you are going to get a fraction out of this is if your exponent is negative. Now, we got to worry about this 27. Do you know off the top of your head what power goes on 3 to make 27? Most probably you do, and it's 3. But if you don't know it, or you get a bigger number on the test, do your division. 3 into 27 is 9. 3 into 9 is 3. 3 into 3 is 1, and there's our third. But the reason it's negative is because we created a fraction. Some of these down here require a little bit more work. You can't deal with a radical. The radicals must be converted to rational exponents. So my first step on this is to rewrite this as log base 5 of 5, because that stays 5, and I need to come up with the power, and this power is the 1/3. Where does the 1/3 come from? The inside power, which is 1, goes on top. The index goes on the bottom. This is an identity. Log base 5 of 5 to the 1/3 is just 1/3, because that cancels out. Same steps here. I'm going to write this as log base 2 of 2 to the 1/5. That cancels out. I'm left with the 1/5. Back to having to do a little bit of work here. Put equals x. This is now 8 to the x equals 4. Now there is no common base right here. There's no power you put on 4 to make 8. But both of these could be rewritten as a power of 2. 4 is 2 squared. 8 is 2 cubed. All of that raised to the xth power. Using your exponent laws, this is 2 to the 3x equals 2 to the 2nd. If those two expressions are equal and the bases are equal, then these exponents must be equal. That's all we have to do is solve. 3x equals 2, divide by 3, and x is 2/3. Some more with the same definition. Put your x here. Now this is also an identity that's worth memorizing. If you have the same thing, same number, log base 4 of 4, then automatically your answer is 1. But if you want to do our steps like we did otherwise, there's 4 to the x equals 4. Think about 4 being 4 to the 1, and that explains why it's 1. So anytime you have agreement between the base and this number, automatically the answer is 1. Another identity, 3 to the log base 3 cancels out. All you get is 8. Same thing here, log base 4 of 4 to the 3rd cancels out. You get the 3. Now when you're dealing with ln e to the 5th, the ln and e cancel, and you get 5. Same thing in this format, e to the ln of 300 cancels, and we get 300. So about half of the problems that you would be responsible for on the test under these directions are going to be identities. So you need to look at your notes and memorize those identities. Otherwise, set things equal to x. These problems here are asking me to solve, and you want to convert to the exponential form. So that's 3 to the 2nd. 3 to the 2nd equals x plus 2. 3 squared is 9 equals x plus 2, which means x is 7. Same steps for this one. 5 to the 2nd equals x plus 5. 5 squared is 25. Solve that by subtracting 5 from both sides, and you get x equals 20. When you are asked to find the domain of a log function, all that matters is that this right here is greater than 0. You cannot take the log of a negative number. You cannot take the log of 0. So all you have to do is take this part, which is called the argument, and set it greater than 0. Not greater than or equal to, just greater than. Add 8 to both sides, and you have x greater than 8. Interval notation on that is 8 to infinity, and both of those get the curved parentheses. Even though this doesn't have a base, you know that that's base 10, but it doesn't matter. All that matters is this, the argument, being set greater than 0. I would add x to both sides to solve this. Now what this says is 20 is greater than x, but reading backwards, if 20 is greater than x, that means x is less than 20. To do interval notation on that is negative infinity to 20. When you're dealing with less than, it has to begin with negative infinity.